Questions over the homework? So at the start of each lesson, except for the first one, I'll take homework questions. So if there's any of them that you were struggling with, didn't understand, I'll go over them at this point. Questions over the homework? All right. So we've solved quadratics a little bit so far because at 3.13, we solved by factoring using the zero product property, because if two things multiply together to equal 0, one of them must be 0. That's the only way we can get 0. So one of the ways that we can solve quadratic equations is by factoring. Write it in factored form, set it equal to 0, and solve. Now there's two other ways that we'll go over in this part of the chapter to solve. One of them is by graphing, and one of them is by using the square root method. Now, a quadratic equation, one variable, standard form, ax squared plus b equals c. Now, a root of an equation is a solution of the equation where x is equal to 0, where the value of x will make the function be 0. And that's what we're trying to solve for, or solve for our solutions, our x-intercepts, our roots. All of these are just different ways to say the solution. And they're all really dependent on the context of what we're finding. So if we're wanting to find the solutions of the equation by factoring, we'll solve for the factors, our solutions that are the factors. If we're solving by graphing, we're solving for our x-intercepts, the values of x that will make the y value be 0. And each one of these here is doing essentially the same thing. So the first thing we're going to do, or what we're going to do at the start of this lesson, is solve this by graphing. Now normally, especially if we graph this by hand, we need 5 points to be able to graph, which would normally be the vertex and 2 points to the left or 2 points to the right. We did that in chapter 2. But luckily, the graphing calculator will do this for us. So the first thing you need to do is turn the graphing calculator on. So once we get it turned on, we're going to hit y equals. Y equals. So there we go. Are we all able to find y equals? Yes, sir. If you're having trouble, you might look at the board, because again, it is highlighted in red on that calculator. Now we should have a screen like this here. Now,
there are charity club T-shirt forms in the office for anyone who wants to buy one. Thank you.
If there's any equations, all right, guys. If there's any equations typed into y1, y2, y3, all the way down, clear those out. So scroll up or down to it and hit clear. So I think all of them should be blank. Yes? Yes, sir. So what we're going to do is we're going to type this equation into y1. So the first thing we want to type is x squared. To type our x button, we're going to hit the button next to alpha. Set x, t, theta, n. So we have x. Then we need squared. So it's, did we all find the square button? Yeah. Okay, then the next thing is minus x minus 6. So we have x squared minus x minus 6, yes? Questions on how we got to this point here? So what are we wanting to do? We're wanting to solve this by graphing, yes? Hit graph.
What the?
There it is. It said quick
Go to. Enter. We don't need that other.
Oh.
Yep. Hit graph. Yes.
Look at that.
Then minus x. So that same button up there. minus 6. Graph. Was everybody able to get to this here? No? So we all got this here, yes? Now again, when we're graphing, we're wanting to find out what value of x will make the y value be 0. We're wanting to know where it crosses the x-axis. Now we could try to count this out, count over left and right, and see what those numbers are. The other way we can do it is second graph. Second graph. Or second table. This provides a table. So the first list is our x values. The second one is our y values. Again, when we're graphing or solving these here, we're wanting to find out or find what value of x will make the y value be 0. So one of the nice things we can do is what? We can scroll up or down. So, because again, it will calculate any value. Now, yes, it will go infinitely up and down, but I wouldn't go too far up or down because you might have to go the other direction later. Yes. So, what is one of the values of x that will make the y value be 0? Negative 2 and 3, because at 3 the y value is 0. At negative 2 the y value is 0. With these quadratics we will have two solutions. They may not be unique, they may be the same solution, but we will have two. So for us here, x is equal to negative 2 and x is equal to 3. Now, if we want to check, all right, guys, so if I want to check and make sure I got the correct solution, we can. Because I can plug negative 2 back in for x. So it'd be negative 2 squared minus negative 2 minus 6. So again, this is just checking, just to make sure we got the correct solution. Now, negative 2 squared, negative 2 times negative 2 would be positive 4. Negative 2 is going to be plus 2. Minus 6. Well, 4 plus 2 is? And 6 minus 6 is? So that is a solution. It did give us a value of 0. The other solution we had was 3. And if I plug it in for x, we get 3 squared minus 3 minus 6. Well, 3 squared is 9. Negative 3 is just negative 3 minus 6. Well, 9 minus 3 is 6, and 6 minus 6 is 0. So both of those are solutions. So, again, when we look at the graph, we're looking for what values of x make the y value be 0. So here at negative 2, what's the y value? And at 3, the y value is? So the values of x that make the y value be 0, or our solutions, are negative 2 and 3. And that's it. Questions on this here? Now again, for this to work, we need this equation equal to 0. And for most all of our solving with quadratics or these higher degree polynomial functions, we need the equation equal to, there's only two ways to solve that we won't have it equal to 0. One of them we'll do one problem today, and that's the square root method. The other is completing the square, and we will do it at a later time. But with any of these here, we need this, especially this one here, equal to 0. So what can we do to get this equation equal to 0? Minus 4x from both sides. Because 4x minus 4x is indeed 0. Our negative 2x squared, negative 4x, and negative 2, none of those are like terms, so we can't combine them. So what it'll give us is negative 2x squared minus 4x minus 2. Now, if we were solving this by factoring like we did the other day, the first thing we would need to do is factor out a greatest common factor before we start our two sets of parentheses. And again, we'd want the first term to be positive, not negative. But for this here, and especially with the graphing calculator, it really doesn't matter. Because as long as we get it equal to 0, we can hit y equals. I would hit clear. Because I want to clear that function out, I'm plugging in a different one. Because what we're plugging in is starting off with what? Negative 2x squared. Because the first term, if it is negative, we have to put a negative. Our next term is minus 4x. If you put negative 4x, it will give us the wrong amount. We have to do minus 4x minus 2. Now, if you put minus 2x squared instead of negative 2x squared, it will give you an error. And the reason for that is because minus 2x squared, it's looking for a number in front of it, so thinking there's supposed to be something subtracted from it. The leading number, if it's negative, we have to put the negative. All the rest we would use minus. Are we able to get this typed in? Yes. Because after we get it typed in, we're going to hit what? Graph. Did you all get a graph that looks something like this here? Let's see. Hit y equals. So you typed in, so let's look back. So we had what? Did everybody get the same graph? If not, yeah. So again, we're looking for where it crosses the x-axis or really intersects the x-axis. Because does this one look like it crosses it? Not really. It looks like it does touch the x-axis and goes back down, yes? In mathematics, we call this point where it touches the x-axis, to have even multiplicity. And all that means is that at that point, it has an even number of zeros. So here, what looks like negative 1, we can go second table, which is indeed negative 1. Negative 1 does give us a y value of. So that means there's an even number of zeros at that location. Even number of solutions there. Well, for us, we'll have 2. That means x is equal to negative 1 and x is equal to, well, negative 1. It still has 2 solutions. They're just both negative 1. And yes, that also means if it does cross the x-axis, is what we call it as an odd multiplicity. There's an odd number of zeros there. For this chapter, it means that there's going to be 1. 1's an odd number, so we have only 1. So for us here, x is equal to negative 1. We don't have to list it twice. We only have to list it once. Questions on this so far? We ready for the next one? X squared minus 8x plus 12 equals 0. Well, that's kind of nice because the equation is already equal to 0. So we can pull the graphing calculator up. Go to the graphing calculator. What's the first thing we'll hit? Y equals, and then clear. Then we'd have x squared minus 8x plus 12. And once we get it typed in, we can hit graph, or if we want to, we can go second table too, yes? Looking at graph, we do get this graph here. Second graph, I see one of the solutions is what? 2 and 6. Because again, we're looking for what value of x makes the y value be 0. We're not so much 0, 12 is where it crosses the y-axis. So our main focus is what value of x will make the y value be 0. So our 2 points, our 2 solutions are x equals 2 and x is equal to 6. Now x equals 0 can be a solution, but that's only the case if the y value at x equals 0 or when x is 0 is also 0. Questions on any of this here? Questions on anything we've done so far? We ready for the next one? Okay. All right, guys, let's focus in. Number 3, 1/2 x squared equals 6x minus 20. Is this equal to 0? So, we'll need to get this equal to 0. How can we get it equal to 0? We can subtract 1/2 x squared from both sides. Because our 1/2 x squared minus 1/2 x squared would be 0, is equal to negative 1/2 x squared plus 6x minus 20. Questions on how we got to this point here? We good with how we got here, yes? Now with factoring, if we wanted to factor this, we would need to get that number in front of x squared to be an integer, not a rational number. It's going to be easier to work with integers, not fractions. So we'd have to go with that there. Now the nice thing with the calculator is that the calculator does not really care, it doesn't really matter that the first number is a fraction. So the first thing I need to type in is the 1/2. Alpha, our green button, y equals, enter. Alpha, y equals, enter. And we can type in our negative 1/2 x squared plus 6x minus 20. Questions on how we type that in? Yes. Alpha, so green button, y equals. So it's what we've been doing to get to that screen. So up at the top, yep, enter, yes. So alpha, y equals, enter. There you go. Yeah, if you have any other questions, let me know. Was everybody able to get the fraction? Yes? Now, the 83s are the ones that I'm letting y'all check out how I said that there's one main difference between these and the 84s. It's fractions. It won't let you type a fraction in like this. So there's a few ways we can do this. One, I can convert it from a fraction to a, what's negative 1/2 as a decimal? So negative 0.5 x squared plus 6x minus 20. Well, a fraction is just another form of dividing, because you're really just dividing the numerator by the denominator, the top by the bottom. So another way I could type this in, especially in the 83s, well, negative 1/2 is the same as negative 1 divided by 2. We just have to put it in parentheses. X squared plus 6x, not apps, x minus 20. all of these here are the same equation. They're just different ways for us to write the negative 1/2. Questions on this here? So I would turn it into a decimal, especially if it's a nice decimal, 0.5. Negative 0.5 is a nice decimal. 1/3 is not going to be a nice decimal. It's repeated. So we can do parentheses 1 divided by 3, close parentheses, and get the same answer. Okay? You only have to type one of these in. You don't have to type all three. Questions on this so far? Now this is going to happen pretty quickly, but I'm going to hit graph, and it's going to graph all three of these. So we'll see the first graph is going to change colors, and then it's going to change colors again. So if I hit graph, it'll graph blue, red, black. They're all the same function, so it just graphed it right over the top of each other. Okay. Questions on this here? So where does it cross the x-axis? It doesn't. So that means there is not a value of x that will make the y value be 0. So that means this here has no real solutions. It doesn't have no solutions, it has no real solutions. There are solutions to this equation. There are values of x that will make this be 0. Those solutions are just not real solutions. Because we did talk about this not a whole lot. It was just briefly mentioned at the beginning of the year that there are such things as non-real numbers. We call them complex numbers. Those are the type of solutions we'll be getting for this here. Yes, sir. Yes. Questions on this so far? So for the most part, we can say that graphing is nice, but as we just saw, it cannot solve all of them. Because here, if it doesn't cross the x-axis, we can't find the solutions by graphing. Questions on any of this so far? We ready for the next one? 4x squared minus 12x plus 9. Well, that's nice. It's already equal to 0, yes? Try and grab the graphing calculator, go y equals. Here, I'm going to have to clear all three of those out. 4x squared minus 12x we see that it does intersect the x-axis. So it does intersect at that point there. We can go second table. What value of x makes the y value be 0? Is there one listed there? Ooh, that got exciting. Forgot that was empty. Is there one listed? No. So there is a solution. It's just not it's not an integer. It's rational. It's fractional. Graphing works nice, especially if the solutions are rational, or integers really, because we can find the fraction, but we really have to have an idea of what the fraction is. Because is it going to be 0.25, or is it going to be 0.50, 0.75? We don't really know, so we can try to start slicing this up to get there. So because what's interesting is if I know, I'll do this here, graph, second graph. If we're able to mess with the table and know how to mess with it, well, not so much know how to mess with it, but know what to split it up into, well, 1.5 does give us a value of 0, yes? Well, the only other way to do this is to factor, and luckily this does factor. So let's go through factoring to solve this. Here, we'll be doing some more factoring later to get the table that way. Yeah, because the only downside is if we know what the table split should be. Now, factoring this here, let's go on and factor it. We'll do some more later, but we'll do one here. First step, to factor 4x squared minus 12x plus 9. Is there a greatest common factor between these three terms? A number that will go into all three. 3 will indeed go into 12 and 9. But 3 and 4 don't work. 4 and 12 have a common factor of 4, but 9 throws that off. So, all right, guys. So we'll have two sets of parentheses with 3 spaces. If the third term is positive, so we're going to find the signs. That's our third step. And to find the signs, if the third term is positive, the signs are the same and they match the sign of the middle term. If the third term is negative, the signs are opposite. So here, the third term is positive. Since the third term is positive, the signs are the same and match the sign of the middle term. Well, our middle term is negative. And part of the reason this works this way, because again, to get that third term to be positive, well, the only way we can have a positive is if both signs are positive or both signs are negative. Here, both signs are going to be negative. Our fourth step is to find the factors of the first and third term. So our 4x squared, well, the factors of x squared are x and x. Factors of 4 are 1 and 4 or 2 and 2. Which one of them do we want to find or use first or check first? Yeah. I'm going to go 2 and 2. Factors of the third term, factors of 9 are 1 and 9 or 3 and 3. 3 and 3. And even though we're solving, since we did factor, we want to check for the middle term. Now, I did explain these to them. I just want to point out one thing, because normally when we check, especially in the book, most books say we need to check the whole thing. We need to check every single product. And it's not that this is wrong, because it would want to check 2x times 2x. Well, where do we get 2x and 2x from? Well, they're the multiples or factors of 2x squared, yes? That's where I got them. Why do I need to check and make sure that they do multiply to get 4x squared? Does that make sense? If they're factors of it, they're going to multiply to go to get back to this here. No real reason to check that. Does that make some sense? Negative 3 times negative 3. Well, that's the factors of 9. The only way that those won't work is if I got the wrong factors. So that works. So we do have those factors, so there's no real reason to check those. The main thing I'm checking for is the middle term, which comes from our 2x, possibilities of 2x times negative 3, which is negative 6x. Negative 3 times 2x is negative 6x, which does indeed give us negative 12x. Because depending on what factors of 4x squared I pick and the factors of 9 I pick, will cause that middle one to change. This is the only arrangement that works. So if I picked 1 and 9 or 1 and 4, we would get a different middle term. Does that kind of make sense? Questions on this so far? We have two things that multiply together to get 0, so one of them must be 0. So either 2x minus 3 is 0, or so for this first one here, the first thing we can do is add 3 to both sides, which will tell us that 2x is equal to 3. Next thing we would do is divide both sides by 2, so x is equal to 3/2. Well, I think we know how the other one was solved, but let's go on and solve it anyways. First thing we would do is add 3 to both sides. Telling us 2x is equal to 3. Then we would divide both sides by 2. So, again, this quadratic has 2 solutions, yes? X equals 3/2 and x equals 3/2. It's the same answer, yes? It does have 2 solutions. They're just not unique solutions. We just have a repeated solution. Questions on this here? All right. All right. This is our next problem. Now, it says to solve this by using the square root method, yes? We haven't gone over the square root method yet. So, if, again, I would watch at this point, because I'm going to be doing a lot of writing, erasing, going back and forth. If we treat this like we've had so far, well, if I want to graph it, I would need to get this equation equal to 0. So, again, don't write this, just kind of watch. To do that, we would subtract 49 from both sides. So we have 4x squared minus 80 is equal to 0. So again, I would watch this. I wouldn't so much write this yet, because I am going to erase everything at a certain point. Window, table set. I'm going to reset this back to 1. So we have 4x squared minus 80. We see that this does cross the graph at 2 spots, yes? Do they look like nice intersections? Really? Because if I look at the table, well, table set, I want to start at 0. Well, I don't see any zeros.
They're crossing the y-axis.
Yes, between -4 and -5, it is crossing the y-axis. Because the y value went from what? Negative to positive, yes? So the only way you can go from negative to positive if that y value is 0 somewhere between -4 and -5, yes? We call that the intermediate value theorem. If between 2 given points, 2 given x values, the y values go from negative to positive or positive to negative, there has to be a solution between those 2 points. That's all the theorem says. But we don't know what that value is. And unfortunately, because I do know what the answer is, it's not a rational number. So no matter how we cut, or did a 0.5, 0.25, any of those there, it won't give us that value. So here, graphing is out. I can't really use the graphing calculator or graph it to get to our solution. Well, factor, we do have 2 things being subtracted, yes? Is 4x squared a perfect square? Can we multiply something by itself and get 4x squared? Yes, what is it? 2x, yes, because 2x squared, 2 times 2 is 4, x times x is x squared. What times itself is 80? Well, we can check. Second square root 80 is 4 squared is 5, so is 80 a perfect square? So can I take the difference of perfect squares? No, so is it factorable? No. Because even if we tried factoring, we need to get a middle term of some. This here is a good example that factoring doesn't always work. Graphing works on some of them, factoring works on some of them, but it doesn't work on all of them. Square root method. Square root method is nice if we do not have a middle term. We do not have an x to the first power, or all of the variables are located inside of a parentheses being squared. So if we look at this here, the only variable we have is x squared, yes? First step of the square root method is to get the term being squared by itself. The first part of the square root method is to get the term being squared by itself. So what's the first thing, or what is one of the things that's attached to our x squared, or that side of it? Because we do have the 4, but we also have the what? The negative 31, yes? It's going to be easier to move it first. So the first thing we can do is what? We can add 31 to both sides, which tells us 4x squared is equal to 80. Is x squared, the term being squared by itself? Well, not quite. What do we have with it? So we need to do what? We need to divide both sides by 4. So what we're left with is x squared is equal to 20. So at this point, we're trying to figure out what times itself is 20. So again, what did we call this method? The square root method, yes? And I think you've learned up to this point, mathematicians aren't, I mean, they're a little creative, but not for the most part. They name stuff as it is, yes? So that's the only thing we haven't used so far that's a part of square root method. We haven't used the square root. We're going to take the square root of both sides. So we're going to apply a square root to both sides. So the square root of x squared is x. That's the nice part about this, is because the square root and square will cancel. So as the square root is trying to figure out what times itself is that number, and a square is multiplying a number by itself. They undo each other. Now we need to figure out what the square root of 20 is. So luckily, the 30xs will take the square root of 20, which is, and we'll leave it in radical form, 2 square root of 5. Yes? Now, whenever we take the square root, more specifically, whenever we take an even root, for this chapter, we're mainly going to be looking at square roots, but fourth roots, sixth roots, eighth roots going on, we have to add a plus or minus, positive or negative. Because again, we're trying to figure out what number times itself is 20, yes? Or what number is squared? Well, 2 square root of 5 squared is 20. Negative 2 square root of 5. Because again, I said we had to put this plus or minus the positive and negative case, yes? What do you think negative 2 square root of 5 squared is going to be? And this is the same even with 9. The square root of 9 is 3, yes? Because 3 times 3 is 9. Negative 3 times negative 3. A negative times a negative makes a, and then 3 times 3 is 9. So the square root of 9, if we had x squared equals 9, x would be positive or negative 3. Now, in geometry, when we talked about something like this here, we took the square root. We didn't put the plus or minus. Because in every case where we were talking about this in geometry, we were talking about a distance, a length, a unit of measure. Distance is always positive. We would not talk about the negative case because it does not apply to the given setup. Now, there is a third step. Solve for x, solve for the variable. Here, the variable is by itself, so we are done. X is indeed equal to positive or negative 2 square root of 5. questions on this here? Trying to remember what. Yep. So we good with this here so far? Do you want to see a nice little trick? Grab the graphing calculator. So I already have this typed in. Go on and hit y equals 4x squared minus 80, because that's what we got it equal to 0. And once you get it typed in, hit graph. We do get this here. Yes? Were we all able to get here? Now, as we've seen, 2 squared of 5, negative 2 squared of 5, these are not nice numbers. They're irrational numbers. Second, trace. Second, trace. So, might need. Four x squared minus 80. Second, trace. It's right next to graph. Once you get it typed in. Did we all get a menu that looks like this here? Yes? The first option is what? Value. Go on and select it. Now, if you notice at the bottom it has x equals, yes? What it's wanting and what it's asking is you to tell it the value of x. So what was one of the solutions we found? 2 square root of 5, yes? So type in 2 square root of 5. The square root is second at x squared. If you have trouble typing it in, let me know. Hit enter. And what does it say the y value is? So 2 square of 5 is a solution, yes? Yep, so approximately 2 squared of 5 is 4.7472,136, going on. If I want to check the other value, we can go what? Second, trace value. But this time, I'm not going to plug in 2 square root of 5. We're going to plug in what? Negative 2 square root of 5. And we also get so will this method actually tell us the values of the solution? Well, yes and no, because it will tell us that it is equal to 0. But in order for us to know that it's 0, we have to know the value of x. We have to know the solution. But we're going to stop here. And we'll pick this up tomorrow.